Lesson Overview, Chemical Reactions Unit, Lesson 2.2, Explaining Chemical Reactions. In this lesson, we use the digital simulation to investigate chemical reactions at the atomic scale, and then construct verbal explanations about how atoms can rearrange into new patterns to form new substances during a chemical reaction. Scale, proportion, and quantity and patterns are cross-cutting concepts. Step-by-step plan includes step 1, completing the warm-up and handing that in. Step 2, you're going to use the simulation to compare substances that react and those that do not. You're going to be given 2 pairs of substances, 2 of which react with each other and 2 do not. Answer the questions provided and hand that in. In step 3, you're going to use the vocabulary terms provided, chemical reactions card provided, and tokens to explain reactions. You're going to need to substitute the tokens with some other objects, maybe coins or something similar. And then in step 4, you're going to use the sim to find a single substance reaction and respond to the question provided, and then hand that in. The unit question, to remind you, is how do new substances form? The chapter question we're still working on is how did the rust form? And this investigation question is how do substances change into different substances during chemical reactions? Amplify Science, Chemical Reactions Unit, Chapter 2, Lesson 2.2, Explaining Chemical Reactions. We begin in the lesson brief where we have access to the digital resources if necessary. In the warm-up, you're testing a single substance in the simulation. So you're going to open up the simulation. You'll end up in laboratory A mode like we did before, and then add substance, add the water. So follow the instructions and observe what happens and reply yes or no and hand that in. In step 2, in the simulation, so you might as well leave it open. You're going to be in laboratory A again and follow these instructions where you're pairing up substances as to whether or not they'll react with one another. So be sure to follow the step-by-step instructions. There's questions to respond to when you're finished, but we do want to explain a little bit more about what's going on. So yesterday we saw a chemical reaction could happen when we mix 2 substances. That evidence suggests that claim 3, the iron pipes in the fertilizer changed into rust, is possible. However, we also have some evidence that chemical reactions can happen with only one substance. This means that claims 1 and 2 are also possible. A chemical reaction could have changed the pipes of the fertilizer into rust also. Now, if you need to refresh your memory about the claims, go ahead and back up and take a closer look at them. You'll be presented with them again by the end in the next step. During certain tests in the sim, you may see lab conditions listed during the testing phase. These lab conditions include high temperature, water present, electricity, which was the lab condition when we tested the water by itself. That was in the warm-up. These lab conditions are included in the sim, so you can observe certain substances changing in ways that would be difficult for us to set up in our classroom. You've seen the evidence that substances can change into different substances. In the last lesson, you learned that these changes happen during chemical reactions. However, we haven't yet determined how substances change into different substances during a chemical reaction. In this lesson, you will investigate this question by making detailed observations of different types of chemical reactions in the simulation. In step 3, you're going to be using a physical model to demonstrate what's going on. Before you do, I have some projections to show you and a modeling tool that they only give the teacher. So we're taking a look at the first projection, and again, if you need to go back to the lesson brief to open the projections, you can do so. But this is chemical reaction card A. Here's hydrogen chloride and sodium hydroxide being mixed as the reactants, making the products water and sodium chloride. And you notice that each atom has its own sphere color with a label. In your case, you're going to be using tokens to represent those. So you would have, if you were in class, you'd have a white token with an H, you'd have a green token with a Cl for chlorine, one for sodium, again, oxygen and hydrogen. You'd have a number of these tokens that you could rearrange. And then in the second situation, they give you a second reaction card, the sodium chloride with silver nitrate, making sodium nitrate and silver chloride, and you would model that as well by arranging tokens where you think they go. We'll take a look at a modeling tool, how that might happen. And the key concept here is during a chemical reaction, atoms do not change from one type to another. During a chemical reaction, atoms rearrange to form different groups of atoms. So the atom itself stays an atom, but they rearrange into what we refer to as molecules. So we'll take a look at the actual sorting tool that you might be using on paper there at home. Grabbing, I don't know, what if you grab like dimes, pennies, nickels, something to represent each of the atoms. And the idea here is that we can take these tokens and place them where the spheres are, and then model how during a reaction, if a reaction occurs, how those tokens then get rearranged in different combinations. So there we had two whites coming apart and two reds coming apart, and they remix as, let me grab some more tokens, a red with two whites and a red with two whites. So they've rearranged into different combinations. Instead of pairs of similar colors, now we have triplets of mixed colors. You're going to again represent that on paper with your cards and your tokens of your choice. Now that we're back looking at the actual student screen with the instructions, again, follow those instructions. Keeping in mind the word bank, you want to be able to use these words to describe what's happening, thinking about the investigation question, how substances change into different substances. And then in the second screen, again, you're given the actual image of the evidence cards. If you don't want to print the evidence cards out, or I should say chemical reactions cards, sorry, you can go back to Classroom, go to the folder, Lesson 2.2, open up the PDF and use those, or you can imagine here on your screen, maybe slide tokens around in front of you on a table to represent this reaction right here, and then move on to the next activity. In step 4, you are finding a single substance reaction. In other words, there are some reactions that happen with one substance reacting in air or with some other environment where they're not intentionally mixed together. So you're going to open up that tool, and you actually as a student get to use this tool. You've seen it before. We are in our chemical reaction simulation. I want you to have the simulation open. As before, you're going to add a substance. You're going to go select a single substance, observe, and see whether or not a chemical reaction occurs. If it does occur, then you can answer the question below. If it doesn't, you're going to have to search for other elements, other substances that you think might react all on their own. So it might take you a little bit, a few tries, trial and error to get this figured out. But once you do, respond back in the space below and hand that in, and that will complete lesson 2.2.